Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than?
Reports this morning that Chinese tech company Huawei is ramping up to test its newest and most powerful AI chip, which would be a competitor to chips made by NVIDIA. Christina Partsinevel is here with that story to evaluate the threat. Hi, Christina.
The satellite images were unmistakable. Deep in Shenzhen's Guanlan district, construction crews worked around the clock, erecting massive structures that would soon house some of the world's most advanced semiconductor manufacturing equipment. This wasn't just another factory, it was Huawei's declaration of technological independence, and it was happening right under the nose of American sanctions. The discovery sent shockwaves through Washington. For years, U.S. policymakers had believed that cutting Huawei off from advanced chip technology would cripple the Chinese tech giant. Instead, they were watching the birth of something unprecedented, a complete semiconductor ecosystem built from scratch, designed to challenge the very foundations of American technological dominance. Inside the sprawling complex, 3 interconnected facilities were taking shape. The centerpiece was Huawei's own manufacturing plant, where engineers were preparing to produce 7-nanometer chips, the kind of advanced processors that power modern smartphones and artificial intelligence systems. This wasn't supposed to be possible. When the U.S. blocked Huawei's access to Taiwan's TSMC and other foreign chip manufacturers, experts predicted it would take China at least a decade to catch up. They were wrong. What we're witnessing is nothing short of a technological miracle, observed Dr. James Chen, a semiconductor industry veteran who spent 20 years at Intel before becoming an independent analyst. Huawei has compressed what should have been 15 years of development into less than 3. The implications are staggering. The numbers backed up his assessment. By early 2025, Huawei had already achieved a 40% production yield on its Ascend 910C AI processors, nearly double what they managed just 12 months earlier. This wasn't just incremental progress, it was a quantum leap that put profitable mass production within reach. The company was planning to manufacture 100,000 units within the year, each one a testament to China's growing technological prowess. But Huawei wasn't working alone. Adjacent to their main facility, 2 strategic partners were setting up shop. SkyCarrier, a company that emerged from Huawei's own research laboratories, was installing equipment to produce deep ultraviolet lithography machines, the complex tools needed to etch circuits onto silicon wafers. Next door, SwaySure was preparing to manufacture memory chips that would feed directly into Huawei's supply chain. The arrangement was clever, perhaps too clever. Officially, these were independent companies. In reality, industry insiders knew better. Personnel moved freely between the facilities. Technology was shared. Funding flowed from the same government-backed investment vehicles. It was a shell game designed to circumvent sanctions while building a fully integrated semiconductor supply chain. The Americans thought they could strangle us with sanctions, a senior Huawei engineer confided during an industry conference in Shanghai. Instead, they forced us to innovate. Every restriction became a motivation. Every closed door pushed us to build our own. The scale of Huawei's ambition became even clearer when satellite imagery revealed another massive construction project near Shanghai. Here, the company was investing $1.66 billion in a research and development center that would span an area equivalent to 224 football fields. With capacity for 35,000 personnel, it would become one of the largest technology research facilities on the planet. This wasn't just about catching up anymore. Huawei was positioning itself to leapfrog the competition entirely. The Cloud Matrix 384, their latest AI chip cluster, integrated 3hit84 Ascend processors using cutting-edge optical technology. Performance tests showed it outpaced NVIDIA's comparable systems by 67%, while offering triple the memory capacity. Yes, it consumed more power and the software wasn't as mature, but for Chinese companies cut off from NVIDIA's products, it offered something priceless, an alternative. The ripple effects were already visible across China's tech sector. Since 2019, Huawei's investment arm, Hubble, had poured money into over 60 semiconductor companies. From carbon nanotube wafer specialists to packaging material producers, they were methodically building every link in the supply chain. Each investment was a brick in the wall of technological self-sufficiency. People don't understand the psychology at play here, explained Professor Liu Wei from Tsinghua University's School of Integrated Circuits. For decades, China accepted its role as the world's factory, assembling products designed elsewhere. The sanctions changed everything. They transformed semiconductor independence from an economic goal into a matter of national pride. The transformation was remarkable. Where once Chinese companies competed for access to foreign technology, they now race to develop domestic alternatives. SMIC, China's largest chip manufacturer, worked hand-in-hand with Huawei to refine production processes. SMI provided engineering support. Dozens of smaller firms contributed specialized components and materials. Yet challenges remained formidable. The U.S. government, recognizing the threat, had already added Sci-Carrier and Shuai to its entity list, citing concerns about military applications. This move blocked American companies from supplying any technology to these firms, forcing them to source everything from Europe, Japan, or domestically. More critically, semiconductor manufacturing remained one of the most complex industrial processes ever devised. A single advanced chip required hundreds of steps, each demanding extraordinary precision. One industry joke held that there were only 3 things in the universe that required nanometer-level accuracy: semiconductor manufacturing, DNA replication, and the ego of a semiconductor CEO. Huawei's relative inexperience showed in subtle ways. Their chips, while functional, consumed more power than comparable Western designs. Software optimization lagged behind hardware development. The ecosystem, impressive as it was, still had gaps that would take years to fill. But perhaps the most significant impact wasn't technological, it was psychological. For decades, the global semiconductor industry had operated on the assumption that no single country could build a complete supply chain. The costs were too high, the expertise too specialized, the equipment too complex. Huawei was proving that assumption wrong, and in doing so, reshaping how nations thought about technological sovereignty. We're entering a new era, predicted Sarah Martinez, a supply chain expert who advised Fortune 500 companies on semiconductor strategy. The old model of global specialization is breaking down. Countries are realizing that in critical technologies, independence matters more than efficiency. The evidence was mounting daily. European nations were launching their own chip initiatives. India was courting semiconductor manufacturers with massive subsidies. Even small countries were wondering if they needed domestic chip production capabilities. The age of technological interdependence was giving way to an era of strategic autonomy. The implications rippled far beyond China's borders as intelligence agencies in Washington began piecing together the true scope of what they were witnessing. By mid-2024, classified briefings painted a stark picture. Huawei wasn't just building a semiconductor facility, they were constructing the backbone of what analysts termed Technology Cold War 2.0. The timing couldn't have been more significant. Just as American policymakers celebrated what they believed was a successful containment strategy, Huawei's breakthrough chips were quietly powering a revolution in Chinese artificial intelligence capabilities. The Ascend 910C processors weren't merely matching Western performance metrics. In specific applications, they were exceeding them. Chinese autonomous vehicle companies reported 23% faster object recognition speeds compared to systems running on NVIDIA hardware. Facial recognition systems powered by Huawei's chips achieved accuracy rates that made even privacy advocates nervous. "What keeps me awake at night isn't just that they caught up," confided a former Pentagon technology advisor who requested anonymity. "It's the speed at which they're now pulling ahead in targeted applications. We're watching decades of American technological leadership evaporate in real time." The economic ramifications were equally staggering. Within 18 months of achieving viable production yields, Huawei had already secured orders worth $12 billion from domestic Chinese companies desperate for chip independence. Telecommunications giant ZTE placed the largest single order, 2.3 million processors for their next-generation 5G infrastructure. Alibaba's cloud division committed to purchasing every Ascend chip Huawei could manufacture through 2026. The message was clear. China's tech ecosystem was rallying around homegrown alternatives with unprecedented enthusiasm. But perhaps the most unsettling development for Western observers was the emergence of what industry insiders dubbed reverse sanctions. Chinese companies that had previously relied on American semiconductors were now voluntarily switching to domestic alternatives, even when foreign chips remained available. The psychological shift was profound. Technological nationalism had replaced pure economic calculation. Beijing quietly encouraged this transition through a web of incentives that made choosing Chinese chips irresistible. Companies that committed to domestic processors received preferential treatment in government contracts, faster regulatory approvals, and access to state-backed financing. The carrot and stick approach was working. By early 2025, over 400 Chinese technology firms had pledged to transition away from American semiconductors within 3 years. The human cost was becoming apparent in Silicon Valley, where thousands of engineers faced an uncomfortable reality. The Chinese market that had generated billions in revenue was systematically closing itself off. NVIDIA's stock price reflected investor anxiety, as analysts calculated that losing access to Chinese customers could slash the company's revenue by 35%. Intel faced similar pressures as server manufacturers in China increasingly turned to domestic alternatives. "We built our entire industry on the assumption that technology would remain global," explained Dr. Amanda Foster, a technology policy researcher at Stanford. Huawei's success has shattered that assumption. We're moving toward a world where technological ecosystems align with geopolitical blocks. The transformation was most visible in China's sprawling technology hubs. In Shenzhen alone, over 200 companies had relocated operations to be closer to Huawei's semiconductor complex. Component manufacturers, software developers, and system integrators were creating an integrated supply chain that operated independently of Western technology. The cluster effect was accelerating innovation in ways that surprised even Chinese officials.
Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than?
Chinese researchers have achieved a significant milestone in the race for semiconductor supremacy. Led by Lin Nan, a team from the Chinese Academy of Sciences Shanghai Institute of Optics and Fine Mechanics has developed an extreme ultraviolet EUV light source platform that operates at internationally competitive parameters. This breakthrough marks a pivotal step toward China's self-sufficiency in producing advanced chips, sending shockwaves through the global semiconductor industry. The stakes couldn't be higher. EUV lithography is the key to unlocking the next generation of semiconductors, enabling the fabrication of chips with nodes below 7 nanometers. These cutting-edge chips promise unparalleled power and efficiency, forming the backbone of everything from smartphones to supercomputers. Until now, only one company in the world, Dutch giant ASML, possessed the technology to manufacture EUV machines. But with US-led export restrictions barring ASML from selling its most advanced models to China since 2019, the country has been left scrambling to develop its own alternatives. Enter Lin Nan and his team of trailblazing researchers. Details of their EUV platform remain closely guarded, but insiders suggest it could be a game-changer. The implications are profound. China currently accounts for over 40% of ASML's global sales, underscoring the country's critical role in the semiconductor supply chain. But with each passing year, the noose of export controls tightens further. In September 2023, under intense pressure from the US, the Dutch government imposed even stricter limitations on the lithography machines available to Chinese chipmakers. The move sparked a frenzied rush of orders from China as companies raced to secure equipment before the restrictions took hold. The stakes extend far beyond the realm of technology. As the United States ramps up its efforts to constrain China's access to advanced computing and semiconductor manufacturing capabilities, the geopolitical landscape grows increasingly complex. Effective October 7, 2022, a sweeping set of export controls aim to curtail China's ability to obtain, develop, and manufacture cutting-edge semiconductor technology. From AI chips to design tools, the measures seek to hamstring China's progress in critical sectors. For companies like ASML, caught in the crosshairs of this technological arms race, the path forward is fraught with uncertainty. CEO Christophe Fouquet has openly voiced his concerns about the mounting pressure from the United States, anticipating further restrictions on the horizon. While ASML expects to weather the storm in the short term, with China still accounting for around 20% of its projected sales in 2025, as China pours resources into developing domestic alternatives, the global semiconductor supply chain is poised for a seismic reconfiguration. In the near term, export restrictions may lead to disruptions and increased costs for manufacturers worldwide. But if China succeeds in its quest for self-sufficiency, it could fundamentally reshape market dynamics, eroding the dominance of established players like ASML. The road ahead is long and arduous. Translating laboratory breakthroughs into commercially viable, mass production-ready systems is a monumental challenge. It will require sustained investment, unwavering determination, and a healthy dose of ingenuity. But if there's one thing China has proven time and again, it's the ability to mobilize resources and talent on an unparalleled scale. As the world watches with bated breath, one thing is clear. The semiconductor industry is at an inflection point. The outcomes of China's self-sufficiency drive will reverberate far beyond the confines of the clean room, influencing everything from the balance of technological power to the future of global trade. In this high-stakes game of geopolitical chess, every move carries profound consequences. The question is, who will emerge victorious in the battle for the Silicon frontier? The tech world stands breathless as Chinese telecommunications titan Huawei prepares to unleash its revolutionary Ascend 910C AI chip into global markets next month. This jaw-dropping development has already sent NVIDIA, America's undisputed AI chip champion, reeling, with an eye-watering $127 billion vanishing from its market value in just 24 hours. The question on everyone's mind: is this the beginning of the end for America's semiconductor supremacy? The announcement couldn't have come at a worse time for NVIDIA, which had recently been barred from selling its flagship H100 chip to Chinese customers due to tightening U.S. export controls. The Trump administration's message was clear. America intended to maintain its chokehold on advanced AI computing power in China. But Huawei had a surprise in store, a homegrown alternative that not only rivals, but in some aspects. What makes this achievement even more remarkable is that Huawei accomplished this feat while cut off from the advanced manufacturing technologies that NVIDIA relies on. The 910C's arrival couldn't be more timely for Chinese AI companies, which have been scrambling for alternatives since the United States restricted sales of NVIDIA's chips. But the path to mass production hasn't been without its challenges. Huawei's manufacturing partner, Semiconductor Manufacturing International Corp., SMIC, is producing the chip using its 7nm N+2 process. But the lack of access to advanced lithography equipment has resulted in yields of only around 20%, far below the 70% typically required for commercial viability. Despite these hurdles, Huawei remains undeterred. The company has already begun distributing samples and accepting orders for the 920NC, with plans to ramp up production to 100,000 units within the year. This ambitious target reflects Huawei's determination to solidify its position in the AI chip market and reduce China's reliance on foreign technology. The geopolitical implications of Huawei's breakthrough are profound. As the battle for AI supremacy heats up between the US and China, the 910C's emergence marks a significant shift in the balance of power. For NVIDIA, the road ahead looks increasingly uncertain. With its access to the lucrative Chinese market now severely curtailed, the company must grapple with the prospect of a formidable new rival on the global stage. As Huawei navigates manufacturing challenges and geopolitical tensions, its progress will be closely watched by industry stakeholders and policymakers alike. The Ascend 910C's impending mass production represents not just a triumph of engineering, but a symbolic victory in China's quest for technological independence. In the high-stakes game of AI dominance, Huawei has just played a winning hand.
Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than?
The moment Huawei's executives walked onto that Shanghai stage in May 2025, they weren't just unveiling new laptops, they were declaring war on the entire personal computing industry. With a single product announcement, the Chinese tech giant shattered decades of Microsoft and Apple dominance, introducing something the world had never seen: laptops running entirely on their own operating system, built from the ground up to challenge everything we thought we knew about personal computers. 23,999 yuan. That's what Huawei is charging for a laptop that folds like a book, weighs barely more than a kilogram, and runs on an operating system that didn't exist in the PC world just months ago. The MateBook Fold isn't just another foldable device. It's a technological declaration of independence wrapped in an 18-inch OLED display that blazes at 1,600 nits of brightness. But here's what makes this truly extraordinary. When you unfold this 7.3mm thin marvel, you're not greeted by Windows or Mac OS. Instead, you're looking at HarmonyOS 5. An operating system that began life-powering smartphones and has now evolved into something far more ambitious. Today, it powers over 1 billion devices worldwide, and it's coming for the PC market that 2 American companies have controlled for decades. The timing couldn't be more critical. When US sanctions cut off Huawei's access to critical technologies from Intel and Qualcomm in May 2024, most observers expected the company to struggle. This wasn't a rushed response to trade restrictions. It was a calculated revolution 5 years in the making. Over 2,700 core patents, more than 10,000 engineers working around the clock, collaboration with over 20 research institutions, and billions of dollars in research and development. The numbers tell the story of a company that didn't just adapt to isolation. They transformed it into an opportunity to build something unprecedented. The MateBook Pro, starting at 7,999 yuan, brings this revolution to the masses. While it maintains a more conventional laptop design, what's running underneath represents anything but business as usual. With 32 gigabytes of RAM and up to 2 terabytes of SSD storage, these machines aren't just alternatives to Windows laptops. They're designed to outperform them in key areas where traditional operating systems have shown their age. What makes this particularly fascinating is how Huawei approached the software ecosystem challenge. Rather than trying to replicate Windows or Mac OS, they created something uniquely their own. HarmonyOS 5 currently supports over 150 applications natively, with aggressive plans to expand to 2,000 by year's end. This isn't about playing catch-up. It's about reimagining what a PC operating system should be in 2025. The artificial intelligence integration takes this even further. Celia, Huawei's AI assistant, doesn't just respond to voice commands. It actively helps create presentations, summarizes meeting minutes, and retrieves information from local documents with contextual understanding that puts traditional assistants to shame. This shift carries massive implications for global technology. For decades, the PC market has been essentially a duopoly, with Windows commanding over 70% market share and Apple taking most of the premium segment. Now, a third player has entered the arena, and they're not playing by the established rules that have governed personal computing since the 1980s. The security implications alone are staggering. By developing their own operating system from scratch, Huawei eliminates concerns about backdoors, data leakage, and foreign surveillance issues that have become increasingly critical in our interconnected world. Government agencies and enterprises dealing with sensitive information now have an option that keeps their data entirely within their control, free from the oversight of foreign corporations or governments. But perhaps the most intriguing aspect is how this fits into Huawei's broader ecosystem strategy. These aren't standalone devices. They're part of an interconnected web of products that communicate seamlessly across platforms. Imagine dragging a file from your smartphone to your laptop with a simple gesture, or continuing a video call from your tablet to your PC without missing a beat. This isn't theoretical. It's happening right now in offices across China. The foldable MateBook represents something even more ambitious than traditional computing. With its 3.3K resolution OLED display and innovative water drop hinge design borrowed from Huawei's smartphone innovations, it's not just about having a bigger screen, it's about reimagining how we interact with our computers. The device transforms from a 13-inch portable to an 18-inch workstation, challenging fundamental assumptions about what a laptop should be. The implications extend far beyond Huawei itself. Other Chinese technology companies are watching closely, and some are already exploring similar paths toward technological independence. If Huawei can successfully challenge the Windows-Apple duopoly, it opens the door for others to follow. We could be witnessing the beginning of a fundamental shift in how personal computers are designed, built, and operated globally. The economic ripple effects are already being felt across the industry. Component suppliers who once relied heavily on traditional PC manufacturers are now recalibrating their strategies entirely. In Shenzhen's electronics markets, where trends often predict global shifts, vendors report unprecedented interest in Harmony OS-compatible peripherals. Mouse and keyboard manufacturers are rushing to ensure compatibility, while software developers are pivoting resources to create native applications. The ecosystem that took Windows decades to build is being reconstructed at breathtaking speed. What's particularly striking is how Huawei has turned technological isolation into innovation acceleration. When access to Google mobile services was severed in 2019, pessimists predicted the company's inevitable decline. Instead, Huawei developed HMS Core, which now serves 730 million active users globally. That same resilience and ingenuity is now being applied to the PC market, with potentially far-reaching consequences that could reshape the entire industry. But success in the laboratory doesn't guarantee victory in the marketplace, and Huawei faces challenges that could determine whether this technological revolution transforms into a genuine market disruption. The first hurdle stands 12,000 miles away in Washington, where policymakers are already scrambling to understand the implications of a major American technology sector facing its first serious challenge in decades. The Biden administration's response has been swift and telling. Within weeks of Huawei's laptop announcement, the Commerce Department initiated preliminary discussions about expanding export controls. This reaction reveals something profound about how the global technology landscape has shifted. For years, American sanctions were seen as devastating because they cut companies off from essential ecosystems. Now, those same restrictions may have inadvertently forced the creation of entirely parallel technological infrastructures. The numbers emerging from Huawei's supply chain paint a remarkable picture of this independence. 93% of components in the new MateBook series are now sourced from Chinese manufacturers, compared to just 41% 3 years ago. The Kirin processors powering these devices are fabricated entirely within China using 7nm technology. Yet here they are, delivering performance benchmarks that rival Intel's latest offerings. More telling is what's happening in software development. Major Chinese applications are rapidly porting to Harmony OS, not as an afterthought, but as a priority platform. WeChat, DingTalk, and Tencent Meeting have all announced native versions optimized specifically for the new operating system. International software companies face a more complex calculation. Adobe has quietly begun exploring Harmony OS compatibility for its Creative Suite. The consumer response has been equally revealing. Pre-orders for the MateBook Fold exceeded 50,000 units within the first week. More significantly, corporate customers are driving much of this early demand. State-owned enterprises across China have begun pilot programs, and several major private corporations have announced plans to transition entire departments. This enterprise adoption matters enormously because it addresses one of the fundamental challenges facing any new computing platform: critical mass. When employees use Harmony OS at work, they become familiar with the interface, understand the capabilities, and often desire similar functionality in their personal devices. This creates a virtuous cycle that no amount of marketing can manufacture artificially. The international implications grow more complex by the day.